Let's figure out how we're going to do this. You've had no lecture at all on this?
No, because he gave this out on Monday, and I wasn't at school on Monday.
Okay.
So,
well, let's start with number one.
okay.
Now, these linear programming problems, and these are kind of unique. This is a unique section of algebra, okay? Linear programming is a very, very advanced subject. You can get a PhD in linear programming, truly. So it's kind of out there on its own as a subject, and you're just being introduced to it here. This is just beginner linear programming. Much like all word problems, your goal, the first thing you have to do is what they suggest you do in D, which is interesting. There's absolutely no way you can do A, B, or C unless you do D first. That's what you need to do first. Define your variables. You'll see why I said that. Okay? Now, read the first sentence and understand it. What's the question the farmer is facing? Only read the first sentence. What's his number one choice that he has to make?
He has 10 acres of land to plant.
What can he plant on
it? 10 acres.
No, he can plant either corn or soybeans. So what do you suppose his decision has to be?
Either corn or soybean.
What are your variables going to be?
So
make X equal and
corn.
Y equal.
So X is corn and then Y is soybean?
Yes, but you have to be a little more specific.
Okay.
And the reason is that when you say corn, corn's got a lot going for it. Its seed costs $200 per acre. Its time to plant is 1 hour. Its profit is $500. There's a lot of descriptions of corn. So what our variable really is the number of acres.
Oh.
That's what I mean by being specific. And with these kind of problems, that's really important. Actually, with all word problems. One of the things I see students do is they're not specific enough. They just say corn, and that can mean the price of corn, profit margin of corn, amount of time it takes for corn. So by specifying that we're talking about the number of acres of corn that we're going to plant, and this is the number of acres of soybean. Okay. Now, let's go to the next part of the problem. 3 inequalities that represent constraints on the system due to the amount of land available. Well, let's start with one of the more obvious ones. What's X plus Y have to be?
How
many acres of land does he have to plant?
10.
So what does X plus Y have to be in terms of an inequality? Remember, X is the number of acres that you're going to plant of corn, and Y is the number of acres that you're going to plant of soybean.
So X plus Y is less than or equal to 10?
Yep. Can't be more. You can't plant 11 acres of vegetables. He only has 10. Okay?
Okay.
Now, they say write the 3 inequalities. The other 2 you just kind of have to have experience at. And it says, hint, you can't plant negative acres. Therefore, X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Okay? So that answers A.
All right.
Next thing we want to do, in order of priority, you really can't solve this in the order that they ask. You can't. You can't write, notice that I can't write these 3 inequalities unless I have already defined my variables. You have to define your variables first. Okay? Write the inequality for B. Write the inequality that represents the constraint caused by the amount of available money. Well, he's got $1,200. So something is going to have to be less than or equal to 1,200, right?
Right.
What is that goes on the left side of that inequality? Corn costs $200 per acre per seed, and soybean costs $100 an acre per seed. Think about it for a second. See if you can come up with what goes on the left side of that equation, or inequality, excuse me. What's the total amount that he's going to spend on corn?
$600.
No, we don't know yet. Put it in terms of a function, a variable. We know he's going to plant X acres of corn, and each acre costs $200 in seed. So how about 200 times X? That will tell you how much he's going to spend on corn. Okay? But he's also got what he's going to spend on soybean. So plus, what's the soybean part?
100Y.
Good. So there's the inequality that is produced by his money limitation. Finally, the fourth part, not finally, because we've got to do E, which is the fifth part. But the fourth part we're going to do is write the inequality that is constrained by the time available. How much time does it have to, it can't go over that amount of time. How many hours?
12.
So something's going to be less than or equal to 12. What is it? Take 1 hour to plant an acre of corn and 2 hours to plant an acre of soybean.
So X plus 2Y is less than 12? Or less than or equal to 12?
Less than or equal to 12, exactly. Those are all of your constraints. Okay? Now, what the function that we're trying to maximize is his profit function, right? That's the only thing he cares about. He doesn't care about whether he has all corn, all soybeans, or part corn and part soybeans. The only thing he wants to do is make the most amount of money. So that's called the objective function. that based on these variables? The last sentence, at harvest, he makes a profit of $500 per acre of corn and $300 per acre of soybean. So his profit is what? Defined in terms of X and Y. How much are you going to make on all of the corn he produces?
$500.
Oh, that's per acre.
Oh. 500x?
That's the total amount. If he has 2 acres of corn, he's going to make $1,000 on his corn. If he has 5 acres of corn, he's going to make $2,500 on his corn. But his profit is a combination of the profit on the corn and the profit on the soybeans. What's the profit on the soybeans?
300y.
Okay, now you have your 5 constraints and your profit function. Now, the next thing you have to do, trying to figure out how to show it because I've run out of space. I'm going to do it over here. I'm going to do it tiny, which will be okay. Now, what I have to do is graph each of these. Okay?
Okay.
And whatever section of the graph is covered by all 5 constraints, that'll be my area, the feasible region. In other words, in this next problem, the green is the feasible region. And notice that that green is a combination of that straight line above the x-axis, and to the right of the y-axis. And that's what we're going to come up with. We're going to come up with some quadrilateral or 5-sided figure. Probably 5-sided. But we don't know yet. Okay?
Okay.
I'm going to start graphing these functions. First, I'm going to put a little label on here. Let's start at the top. X plus y is less than or equal to 10. How do you graph that? That's a straight line. Where's its x and y intercepts? Graph it as an equation, always. That's how you graph inequalities. Just start out by graphing them as equations, and then figure out which side of that line to shade.
Okay, so
what's the x-intercept? If I gave you this inequality here, said what's the x-intercept, what is it? The x-intercept always means that y is 0. By definition, if I'm on the x-axis, y has to be 0. And my y-intercept is when x is 0. Very important concept to remember, always. That's going to come up time and time again. Your x-intercepts are when y is 0, your y-intercepts are when x is 0. So graph just that inequality for me based on intercepts. Where's the x-intercept? Make y 0.
10.
Okay, that point's on our line. Where's the y-intercept?
10.
Okay, that point's on our line. That's a straight line, and it's a solid line. Okay. Now, which side of that line do I shade? Upper right or lower left? In order to figure that out, you have to solve this in terms of y. So if I solve that in terms of y, I get this. Now, look to the y-axis. What does it say? Y is less than that line.
So below.
Yes. And it's always below or above. It's rarely right or left, no matter what the slope is on that line. You always want to define it in terms of the y-axis. So I had to do some algebra there. I had to come up. Now, since I had to do that anyway, I suppose it would have been easier to just do that in the first place and then plot it based on y equal mx plus b. Okay? I could have done that. You'll notice the y-intercept is 10. The slope is minus 1. It's that line. Now, we also know that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. So what I have is that area right there. Okay?
All right.
I'm going to pick a different color. And we're going to do the next one. Now, since we have to know which side to shade, the better way to graph this, let's put it into y equal mx plus b. But let's simplify it first. I can do that, that, and that right off the get-go by just dividing both sides by 100. Now, when we solve that, we get y is less than or equal to minus 2x plus 6 plus 12. Okay?
Okay.
How do I graph that line?
So
Graph it as an mx plus b. You gotta know how to graph y equal mx plus b.
so at positive, so the y-intercept is 12.
Yep. Okay. So I know that point's on my line. It's the slope.
And the slope is down 2 and then right 1.
Okay, that's a steeper slope than my other one. So that's a slope that, well, let's see, my X-intercept is going to be at 6, so should end up like that. Okay? Now, the only thing I'm interested in is regions in common. Okay? Which side of that green line am I on?
Below it.
Huh? Now, my regions in common are there. Notice that y can never really be 12. I only have 10 acres of land to plant. So this region up here where I'm pointing with my cursor, that's not really in our feasible region. Y has to be less than 10 and x has to be less than 10. But I'm narrowing down my feasible region here. Okay? Now I got it down to this area that has the red stripes and the green stripes. Okay, let's go to the next one. Let's use a different color for this one. Let's use blue. And again, let's solve this for y. When we have an inequality, using the intercepts doesn't help a whole lot because you don't know which side to shade. So you need to just solve all of these for y. What's this y going to be less than or equal?
So
Solving for y. So get rid of the x and then divide both sides by 2.
So negative 2x
No,
plus.
I'm dividing both sides by 2. Negative 1/2 x.
Oh, yeah.
Well, plus 6. That's my third constraint. I'm going to graph that. Where do I start?
So y-intercept is 6.
Okay, it's right there. What kind of slope is that? It's more flatter than the 2 slopes I have on there.
So down 1, right 2.
That's steeper or flatter?
Flatter.
The red line has a slope of -1. The green line has a slope of -2. So we're talking about a slope of -1/2. It's flatter. That's what I mean by flatter. It's supposed to be a straight line. Okay? Which side of that blue line are we on?
Below.
Yes. That's all you ever look to. It's right there. Y is less than. That tells you whether it's below or above immediately. No matter the slope. Just always find a point on the y-axis that's less than the line. Well, there's a point on the y-axis. It's less than the line. Looking only at the y-axis. I'm not looking at the x-axis. Okay? So now our area, our final area of interest is only the area included by all 3 lines. You see how I get that area right there?
Yeah.
Okay. Which means that our maximum profit has to be at one of the vertices. In other words, there's that vertice, there's this vertice, there's this vertice, and there's this vertice. There's 4 vertices in this line. What we have to do is figure out the profit at each vertice. Whichever gives us the biggest number, that's our answer. Okay? Let's start at the lower left. That's rarely the answer because how much profit do we make when we produce 0 corn and 0 soybeans? Plug it into the profit equation. Always what you're going to do is whatever the coordinates are on these 4 vertices, you plug into the profit equation. What kind of profit do you get when you don't produce anything?
Nothing.
So that's that profit. Now, let's go to the next easiest point to do. How about that point right there? How much corn is that? How much soybeans is that?
So that's
how much corn is it? This is the corn axis right there.
Right. So corn is
Soybean axis.
None. So no corn.
Okay. So the profit from 0 corn, and what's the y coordinate there? We got it from the blue line.
6.
Okay. So what is the profit on that point? Get your profit equation and just plug the x value in for x and the y value in for y.
So 1,200.
What's 6 times 3?
Wait, yeah, what is 6 times? 1,800.
That's how much you make if you plant just 6 acres of soybean and you leave 4 of your acres unplanted. Okay? Now, let's go to our next easiest point. That one right there. That came from our green X-Intercept. See the green line?
Yeah.
That X-Intercept is what that point is. We know what the Y value is. So I'm looking for the profit of something, comma, 0. In other words, that would be no soybeans. Well,
So
on the green line, let's go up to the green equation. Remember, the green equation came from this one.
right.
Or this one. Sorry to use blue. Tell me the X-intercept. In other words, here you do need to know the X-intercept. And the easiest way to do it is to make Y equals 0.
So X is...
Hold on, I'm sorry. I'm confusing you because this is the equation. Actually, this is. Figure out the X-intercept for this. That is 2x plus 1y is less than or equal to 12. What's the X-intercept on that equation I just wrote?
So X is less than or equal to 12.
No. Make y 0 and solve that inequality.
Oh, I mean 6.
Okay. So that point is 6 comma 0. So that's the point I want. I want the profit I'm going to make when I do 6 acres of corn and 0 acres of soybeans. Well, how much do I make?
3,000.
The objective function.
Yeah, 3,000.
Okay. Well, that's best so far. But clearly that can't be the best. I mean, I know that if I do 6 acres of corn and 4 acres of soybean, I'm going to make a little bit more. I should be able to do that. Okay, so the last point we have to test, and this is usually where your maximum comes from, is on one of these vertices that you have to solve for. Now, the vertex of the point that I just pointed at is where the green line equals the blue line. Okay? So, let me go here and let me do the green line properly. This is the green line. With me?
Yeah.
In other words, that's this line here that I wrote in blue. That's the green line in our graph. And the blue line was this one right here, the very bottom one. X plus 2y has to be less than or equal to 12. No, excuse me. Yeah, X, I want to write this in blue. X plus 2y has to be less than or equal to 12. That's the time constraint. Okay? In other words, where the time constraint inequality crosses the price constraint inequality, in this case, only because we're looking at it at the graph, and I can tell it's where the green crosses the blue, not where the red crosses. Where the green crosses the blue. If I had a bigger chart here, it would show up more clearly. Okay? So, that's going to give us the coordinates of our X and Y.
Right.
Solve
So
that system. Let's make it equals because we're trying to figure out where that point is. Solve that system of inequalities or equations.
so
How are you going to
the
solve
top.
that system of equations?
So
Here, that's equation 1. That's equation 2. Do it by elimination.
okay. Yeah. All right. So you multiply the bottom one by -2.
Okay. So now we have 2x plus y equals 12. And below that, we have minus 2x minus 4y equals minus 24. Did I do that right?
Yeah.
Multiply by -2. Okay. Now I add those two equations, and I get minus 3y equals minus 12. So the y coordinate is 4 for that point. So that point has a y coordinate of 4. And if I go back into either equation and I substitute 4 for y, x comes out to be 4 also. So that is the coordinates on that vertex. You with me?
Yeah.
So the last thing we have to do is figure out what our profit is when we plant 4 acres of corn and 4 acres of soybeans. Plug it into the profit function.
So 2,000 plus 1,200. So 3,200.
Voila! Our magic answer. Now, what kind of farmer do you think can do this math? No knock on farmers, but you're not going to find many that can do this math. And yet, notice what our answer is. We don't use all 10 acres of land.
Yeah.
We only plant 4 of corn and 4 of soybeans, and we make the most profit. We make 3,200 with that combination. All these other combinations are less. And you might say, well, how come I don't just add 2 more acres of soybean? Well, because that violates our time constraint. We have to get the planting done in 12 hours. So this is the combination that produces the greatest profit. And it also is a combination that fulfills all 5 of my inequalities. In other words, it fulfills this one, x plus y is less than 10, x greater than 0, y is greater than 0. It fulfills this one. Notice that 2x plus y is less than 12. And the last one is this one here, and it fulfills that one.
Right.
Or this one. I'm getting confused. There's too many that are alike here. But that is linear programming in a nutshell. All of your constraints are straight lines. You just have to graph them. And graph them on a big enough piece of paper so that you can tell where the vertices are. And some vertices you have to do algebra. For instance, this green one for the next problem, well, I'm going to erase everything we have on here at this point. Okay?
Okay.
Let me do this, in fact. Let me scroll down a little bit to get to this next problem. Let me take a picture of it. All right. This next problem is different in the sense that they give you the coordinates of all 4 vertices. But sometimes there's 5 vertices or 6 in real life problems, because sometimes there's more constraining functions than the 5 that we had on the previous problem. This problem, they don't give us the constraining functions. They go ahead and they draw the graph and they tell us what the feasible region is. That's what that means. The feasible region is the area that's covered by all of your inequalities. Now, normally we would have to figure out these coordinates ourselves, but they give them to us. Nice of them. There's only one problem with this problem. He does not tell us the constraining or the profit, the objective function. He says, how many sparklers and fireworks, there's our variables. X is going to be the number of sparklers, Y is going to be the number of fireworks. How much should they sell to maximize their profit? And he gives us the corner points over here on the right, but notice what's missing. He does not give us the profit equation. It says the profit equation of, and then he leaves it blank, comma.
I don't know why it did that for you. It shows it for me here on this paper.
Fantastic. Tell me what it is.
So it's P equals 2.20 X plus 3.15 Y.
Okay, that's what I called the objective function. The objective function is always the function you're going to test out each of these points on. And whichever one gives you the highest profit, that's your answer. Now, in this case, I'm going to take a guess and say X is the X is going to be the number of DD type sparklers that you sell. Y is going to be the number of WW sparklers that you sell. Okay? That's the way they've labeled it. The x-axis is WW. Oh, I got it backwards, don't I? Here, I do. I didn't look at the graph. I should have. The x variable, that's the number of the WWs. The y variable is the number of the DDs, the dazzling dingbats. They're both sparklers. And it matters which is which. Because remember, we're going to come up with a final answer that tells us how many WWs we should sell and how many DDs we should sell. So we have to know which is which. Now, once again, I'm going to write this. Notice that I have a function of 2 variables here, X and Y. So really, I could have written the profit as a function of X and Y. That's really what this equation is. In fact, let me write it like that because it's more easy to understand. When I use f of x notation, it means that whatever's in the parentheses are the variables you're going to find on the other side. Well, our 2 variables are x and y. If that said p of x, then I would only find x's on the right side of the equation. But it doesn't. Okay, so let's start with the easiest point, the lower left. What is our profit when we sell 0 of each?
Nothing.
Let's go clockwise. What is our profit when x is 0 and y is 255? Remember that our optimum solution has to lie at one of these vertices. It cannot lie in the middle of that area. So we don't have to test anything but the vertices.
Okay.
Okay? So what's the profit at this point right here? That's 0, 255. You're going to need your calculator for this.
Yeah. So 561.
Nope. Got to multiply that. Y is 255.
Oh, crap. Oops. 1 sec. So 255. 3.15. So 803.25.
813.25. Is that what you said?
803.
8 what?
0. 3.
Okay. Let's just work clockwise. Next point I'm going to do is that point that's 180 and 120. So tell me what I should write and what is the answer.
So
P of what?
180, comma 120.
Yeah, that's what that notation means. Means that whatever our function is, we're going to plug in 180 for x and 120 for y. Do that, come up with an answer.
So 180 times 2.2. So 396 plus 120 times 3.05. 378. So that's 774.
Okay. And finally, what's the rest of it?
So
Write the rest of it.
260, comma 0.
And what is that?
572.
So what's our best move for the owners of this fireworks store?
The 180, comma 120.
No. That. You said 803 for that, right?
Oh, yeah, I didn't see that.
We're picking the one that produces the most amount of profit.
Right.
So the one that does that is this point right here, where we produce 0 whistling wee bangs and 255 dazzling dingbats. And it wasn't clear at all. Even after we laid the problem out, like I said, normally that produces your maximum with most of these problems, but not always. Any of the vertexes can produce your maximum. In this case, it turns out to be that one. We're far better off if we don't sell any dazzling or whistling wee bangs and nothing but dazzling dingbats. Okay? Notice we did the problem pretty much identical, except we didn't have to graph these lines. They did the first part of the problem for us by telling us the feasible region. Once you have figured out the feasible region and you know the profit with the objective function, and especially if you know the coordinates of your 4 vertices, then the rest of it's fairly simple. Not hard at all at that point. All right. We got 15 minutes. That might be time to do one more of these. These are long problems. And you can see why. There's a lot to them. All right. Our questions are write the inequalities that correspond to the constraints, graph them, and clearly indicate the feasible region. So this problem is the same as number 1, pretty much. Okay. Now, usually your variables you can kind of figure out from the first sentence. Unlike a lot of algebra word problems where usually you figure out what your variables are by going to the last sentence. Well, not with these. So far we've seen that what's our question that has to be answered? First sentence. What's X going to be? What's Y going to be?
So X is queen, Y is king.
Remember, be specific.
Oh.
Does that mean the price of a queen or the number we're going to make?
So the number of queen mattresses sold.
Number of queen size mattresses that we're going to manufacture. We are a manufacturing company, or we're dealing with one, and we're going to let Y be the number of king size. Okay? Now, let's try to write the inequalities that correspond to the constraints. I'm going to write those right below. So, starting off with the next sentence. No more than 50 queen and no more than 40 king can be made per month. What's X got to be less than or equal to?
40. Oh, wait, no, 50.
What's Y got to be less than or equal to?
40.
Let's go down to the next sentence. At least 60 mattresses need to be made each month. Well, let's put that in an inequality. What's X plus Y have to be?
So greater than or equal to 60.
But the factory can't produce more than 70 mattresses in total. So it's another constraint on X plus Y.
Less than or equal to 60 or 70?
75, sorry, I said 70, but wasn't reading it properly.
Oh, 75.
Okay. Now, there are some more constraints. X has to be greater than or equal to 0 because you can't produce negative number of mattresses, king or queen. So does Y. Okay? So notice we now have 6 constraints. Now, notice there's no objective function here. They're not telling us anything about the profit we make on our mattresses. In other words, this is only half of a problem. This is graph these 6 inequalities and figure out the feasible region. That's all they want you to do. Okay, so I'm going to go up here and let's do the easy ones. Let's do that one. How do I graph that?
So on the x-axis is 50.
What kind of line is it? Is it a line with slope? Is it a vertical line? Is it a horizontal line?
It's a horizontal.
Nope. Remember, vertical lines are always X is some number. Horizontal lines are always Y is some number. Notice Y.
Yeah.
So there's our line. Which side of that are we on?
The left.
The only time you answer left or right is when you have a vertical line.
Right.
because we don't have a y to look to. The only thing we have is x, and it says x is less than, so it has to be to the left of that. Okay? Down here at the bottom, we also know x is greater than 0. We know we're above the x-axis. We know we're to the right of the y-axis. So how about y is less than or equal to 40? How do I graph that?
So it's a horizontal line and then 40 at 40.
At 40. Which side of that are we on?
The below.
Okay. So far, this rectangle is our feasible region. But we've only done that one, that one, that one, and that one. Now we have to do these two inequalities here. Okay. Now, let's, as we know, we're going to wonder about intercepts. But we have to know which side to shade it on. So I think, let's solve that for y. Y greater than what?
So
here, I'm going to write it on the other side because we're going to run out of ability to see it if I keep going in that direction. So here, I'm going to write it right over here. So what does that end up being? Y is greater than or equal to what when it's in mx plus b format? Solve that
50.
for y. That's all you have to do. Solve it for y.
So
You're solving this right here for y. What do you have to do?
subtract x.
Okay, do it.
So y is less than or equal to negative x plus 60.
Greater than or equal.
Oh, yeah, that's what I meant.
Okay. Now we know how to graph that. Where do I start?
So at positive 60 on the y.
On the y-axis. So that's one part of my line. Where's the x-intercept? In other words, I got to figure out, I know what the slope is. It's minus 1. Therefore, the x-intercept has to be 60 also, right? In other words, if I go back and look at the inequality that I've circled, now I want to find the x-intercept. I make y 0. It's also 60. So the x-intercept's out here. And we have a line that goes between those 2 points. Which side of that line am I on?
Above it. So it's that triangle shaded.
Yes. Y is greater than that. Okay, so at this point, it's just that little triangle. And now let's add the fourth one. How do I graph that? I start at 75.
So x plus y, so y is less than or equal to negative x plus 75.
Okay, what's the x and y intercepts?
So the y is at 75, and then x is at 75.
In other words, you're doing that from this, where you're getting the x by plugging in 0 for y, and you're getting the y by plugging in 0 for x. Okay? Well, that's a line that's parallel to our other slanted line. But which side are we on?
Below it.
So our feasible region is that region right there. Okay. Now,
Okay.
had they given us an objective function, we would have to plug in this coordinate, that coordinates, and that. Those are the only 4 spots that could possibly be answers to how do we make the most amount of money. But they didn't give us the profit function. We don't know how much we make on queen size mattresses or on king. They didn't give us that because that wasn't their question. Their question was merely come up with the constraints, the inequalities, and find the feasible region.
Right.
All right. We don't have time to cover it, but 4 looks like it kind of combines all of it. In other words, 4, they're giving us the profit function. Notice that when you see the word profit in these, that's always your objective function. Nobody's profit is to make as many soccer balls as they can in a day. Anybody that owns this company, their objective is to make as much profit as they can, regardless of how many soccer balls or footballs they sell. They merely want to make the greatest amount of profit. So we're going to do this problem exactly like we did all the others. We start out by defining our variables. X is going to be soccer balls that we produce, the number of them. Y will be the number of footballs that we produce, and then go from there. And every question they ask is exactly the same as we've done. And they ask it all here. They ask you the inequalities that are needed. They ask you to graph it and graph the feasible region. Then you have to find the vertexes. And notice the vertices are not that easy, especially the vertices that are not on the X or Y axis. Those require you to solve the 2 inequalities that cross to form that vertex. And you set them equal to one another and solve that system of equations. Okay? And
Okay.
finally, the profit function you're going to get from this sentence right here.
All right.
Obviously, we're going to make $1.50 on x's, so $1.50 times x plus $2.50 times y. That's going to be our profit function. And we'll just plug in all of our vertices into the profit function. Whichever one makes the greatest amount of profit, that's our answer. All right, Demetrius?
All right.
Okay, you picked a bad day to skip class or miss class.
Yeah.
By that I mean this is the toughest subject this is the toughest part of Algebra 2 you're going to get all year. I can't think of anything that's going to be tougher than this.
Okay.
Okay? All right.
All right.
Hopefully I've helped you a little bit. But
yeah.
it's a tough subject. It really is a tough subject. All
All right.
Demetrius, I will talk to you next time. Let me just check. That's Thursday at 4.
Yes.
Talk to you then.
All right.